Yeah, you're all welcome. This is the continuation of what we started already on variation. So this time we're going to be solving what problem that leads to variation. Now, this problem we have, they're all variation problems. So it's either it is a joint variation or inverse variation or maybe direct variation. So that is what we're going to be doing here. But now let's start with solving question 19. So 19 is saying that the electrical current in amperes in a circuit varies directly as the voltage. So I'm talking about the current varies directly as the voltage. So if I say let C be the current and let V be the voltage, that is going to be interpreted as C is directly proportional or directly varies as the voltage. And remember what we did, you want to remove the this variation symbol and introduce a constant of variation. That's going to be C is equal to KV. You see now the K is a constant, right? Now let's move on. Now we are told that when 15 volts, remember 15 volts is talking about the voltage. So when V is 15, that is what it means. Then the current is 5 amperes. So when V is 15, C is 5. So we want to plug in these values. C is 5 and V is 15. So that's going to be like 15V. I mean 15K because V is 15. You see, so V is 15, we have it here, and C is 5. So with all of this information, we just want to get the constant of variation. All right, so that is the K. So when you want to get the value of K, you want to divide everybody by 15, just like that. And when you do that, you see that K is equal to 1 over 5 because you know this cancels out, right? And 5 over 15 is the same as 1 over 5. When you divide the numerator by 5, you get 1, and when you divide the denominator by 5, you also get 5. I mean, sorry, that should be 1 over 3. Sorry, not 1 over 5, 1 over 3. Oh, thank you, thank you, thank you. 1 over 3. Let me clear on that stuff. Yeah, so that is exactly 1 over 3. So now we got the constant of variation. Now, take note, the question still continues. It's asking us to find the current when the volt is 18, when the voltage is 18 volts. Okay, so we want to get the current. So that means, remember, we still have this equation. This is C is equal to KV, right? But now we know the value of K, and that value of K is 1/3, and that is 1/3 of V. Now we want to find the current. We want to find C when V is 18. So that will become 1 over 3 times 18. And of course, when you divide 18 by 3, you're going to get 6. Okay, you're going to get 6 because 6 times 3 is 18. You're going to get 6 amperes. So that will be the answer for this problem on what problem of variation. Okay, so I hope that makes sense. Let's do question 20. This is on the head variation, right? So let's see what question 20 have for us. Question 20 says the current in an electrical conductor varies. Remember, it's still talking about current now. In an electrical conductor varies inversely as the resistance of the conductor. All right, so we're talking about the current in a conductor and the resistance in that conductor. So if we select current and let R represent the resistance, now the relationship between these two guys is inverse relationship. So we're going to write as C is inversely proportional or varies inversely as the resistance, 1 over R. Now introduce the constant of variation, that would be K over R. Now this is what we know. Now the next statement is going to help us get the value of K, which is the constant of variation. Let's read on. It says, if the current is 12 ampere, so if C is 12, so that becomes, remember C is 12, so here becomes 12 equal to K. And what's the radius? I mean, sorry, I said radius, resistance. So if C is 12, which is 12 ampere, when the resistance is 240, so K is, I mean, R is 240. So with this statement here, we're going to get the K, the constant of variation, right? So let's do that really quick and move on to the next step of the question. So to do this, we want to cross and multiply. So you'll be having 12 times 240, and that is equal to K, right? 12 times 240 is equal to K, or you can say K is equal to 12 times 240. And so 240 times 12, permit me to use my calculator, got lazy, 12 times 240, that is exactly 2,880 that's the constant, right? 2,880, that's the constant. Now we know the constant. This equation can now be written as C is equal to 2,880 over R, if that makes sense. So now the next statement is saying we should find the current. What is the current when the resistance is 540? So we want to get the current when the resistance is 540. So C is unknown when the resistance is 540. That would be 2,880 over 540. Now, just so that we understand the workflow of this problem. The workflow, first of all, is to write the equation that talks about the connection of those two materials you're finding this relationship. Then the next is to find the constant of that relationship, which is the constant of variation. And the next is to find the next of with the constant of variation. That's what we are doing here. So 2880 divided by 540, that would be divided by 540. That's around 5.3. So that would be C equal to 5.3 amperes. Okay, so that is just pretty much what it is. And I think that will be all for today because we've already done problem of variation. Okay, so I think that's all. That's basically all. So go ahead and watch this video as much as you can. If you have questions, let us know in the comment section and we're going to see how we can help you. And again, if you want to join our one-on-one section, use the link on the description of this channel and that will take you exactly to our admin and they're going to enroll you in our sections. We do the SAT, the GRE, high school math, middle school math, elementary school math, and just like that, we're going to help you scale up your math journey and help you catch up with your class and even move you ahead in your school curriculum. Thank you for watching. See you in the next class. Have a wonderful day and God bless you. Bye-bye.